Hi, so this screencast is to explain the air rocket activity. Um, and disregard these numbers, these are just an example. I got my numbers from Samantha since I wasn't there on the day I was on senior day. Uh, the first one of these four that I did was the low cap. And the first question asked to sketch a diagram of the situation using arrows to represent the position and velocity of the rocket at 0 seconds. And here we have the work for the low cap. And our number one here just shows our position, our time, and then the velocity of the rocket as it first increased quickly and then slowly decreased speed and then increased as it fell. Our positive was up if, because of just thinking logically, and to me up is positive always. Well, not always, but yeah. And then our number two for the activity was just to sketch a velocity versus time graph and an acceleration versus time graph. And our velocity versus time graph here shows that our rocket started at an initial velocity at a positive velocity over here, and then it as the as the rocket reaches maximum height, it actually decreased in velocity and eventually reached zero at this point here. And then as the rocket began to fall, it began to increase in speed in a negative direction, making it a negative velocity with increasing, as we see right here. Our total time for this was 3.92 seconds, which is our final time, and we figured out that halfway at its maximum height, the time is 1.96 seconds. Since it's a parabola, the time should be half for the maximum height from the total height. Our acceleration time graph here is is just a straight line since our velocity time graph is linear, and our acceleration is the free fall constant or gravity, which is negative 10 meters per second squared, and we have here our final time and our half time. Question 3 went on to ask about what was the change in velocity of the rocket. And we got the change in velocity of a rocket by multiplying our acceleration by our total time. Basically just finding the area here of our acceleration graph. Uh, the area underneath the line, or right here above the line, between our line and zero, or horizontal line here, is the change in velocity. So our change in velocity for this came out to be negative 3.92 meters per second. And my explanation here is change in velocity equals your area of your acceleration time graph. Number 4 went to ask, what was for asking? How fast was the rocket traveling when it was launched? So it was basically, and how do we know? And it was basically asking, what's our V naught? And our V naught is just our acceleration times our time, and our acceleration is negative 10 meters per second squared, which is the free fall constant. So our V naught is just negative 10 meters per second squared times half of our time, since we're using, well, we already know half of our time, which is 1.96 seconds. And it gave us negative 19.6 meters per second. But since at time equals zero, it it was at position zero. It wasn't either negative nor positive, so we took the absolute value, and we got our V naught as being 19.6 meters per second. Number 5 asked, what is the speed of the rocket? Well, is the speed of the rocket? Wait, is the speed when the rocket was launched different from the speed just before the rocket hit the ground? And explain your logic. For this, the answer is no. Since the speed of the rocket is just the absolute value of our velocity, and the V naught, the absolute value of our V naught at our velocity at zero and our final velocity, are equal. There there was no change in speed, same speed. Number six. Number six asks, what is the maximum height of the rocket and how did you figure this out? Well, the maximum height of the rocket is just right here at half of our time, which is 1.96 seconds. So, and if you want to use the velocity time graph, you just find the area of your first triangle, which is just your 1/2 times your base times your height, and our max height here would be 1/2 of 1.96 times our v naught, which is 19.6 meters per second, and we got 19.2 meters. Number 7 asks, was the acceleration different from when the rocket reached maximum height? Explain your reasoning. No. The acceleration is constant even when we reach our maximum height, simply because our acceleration here is the free fall constant, or gravity. And gravity, no matter what, is always constant everywhere on everything. So even though our velocity was 0, our acceleration was still exactly the same. And we can see this in our graphs here. The acceleration never changes. And here we see at 1.96 seconds our velocity is 0. But here at 1.96 seconds it's still negative 10 meters per second squared. Number 8. Number 8 asks, what was the total distance that the rocket traveled and how did you figure this out? Well, since it's a parabola and we knew what the max height was, we knew the distance it traveled to get to that to the halfway point, we just multiplied what our max height by 2 and giving us our total distance, since our max height is just the distance traveled halfway. Since it's a parabola and it reaches the same, it's on the same level, beginning and end. So we just multiplied it by 2 and got 38.4 meters. Yeah. Wait. Yeah. Number 9 asks, what is the total displacement of the rocket and how do you figure this out? Well, the total displacement is 0 because displacement is just a change of your object in regards to position at 0. And our position at 0 and our final position are exactly the same, meaning the total displacement is 0. Number 10. Are your answers different for your last 2 questions? Why? Oh, well, our answers are different, yes, because total distance is just the measurement of the distance the rocket traveled, and displacement is the change in its position regarding its position at time equals 0. And they're just 2 different things. And our change in position is 0, but our total distance traveled is 38.4 meters. Alright, time to move on to the other settings. Over here I give the disclaimer that the explanations given in the low setting are the same for numbers 5, 7, 9, and 10, so I'm not going to go over those. I'm just going to go over the math here. For our medium setting, we had a time equals to 4.9 seconds. Here I drew again the same graph. It's the same idea, it's just a different setting. And same graphs pretty much, just different times and initial velocities. For number 3, we got our change in velocity equals to negative 10 meters per second squared, which is our constant acceleration always, since it's a free fall, by 4.5 seconds. We just rounded our time to 4.5 to make our lives easier. And we got a change of velocity equals to negative 45 meters per second. Our v naught, as always, is our acceleration times our time. We'll have our time here, and it's our way to find it, which we got as negative, 22.5 meters per second. Since our v naught is at 0, it's neither negative nor positive, so we just took the absolute value. you got V naught equals to 22.5 meters per second. Our max height we found by finding the area of this first triangle here with the 1.5 base times height. We took our base 2.25 seconds, multiplied it by our height of 22.5 meters per second, or V naught, and divided it by 2, and we got a total max height of 25.31 meters. Our total distance was just our max height times 2 since it's a parabola, and we got 50.62 meters. For our high setting, we had a time of 5.09 seconds. We rounded it to 5.1 seconds to make our lives easier once again. Once again, the graphs are the same, just the times and the initial velocities are different. Yeah. And our change in velocity here is negative 10 meters per second squared, since it's the constant, free fall constant or gravity, and multiplied by our time, which was 5.1 seconds, and we got a change in velocity of negative 51 meters per second. Over here we have our V naught, which is just our acceleration times our half of our time for this, and we got negative 25.5 meters per second, since our acceleration is still negative 10 meters per second squared, and our half of our time was 2.55 seconds. So we took the absolute value of that, and our V naught is 25.5 meters per second. Our max height is just 1/2 base times height of this triangle, and we got 2.55 seconds as a base times 25.5 meters per second as our height, or our V naught, times divided by 2, and we got 32.51 meters as our max height. Our total distance, we just multiply that by 2, our max height by 2, and we got 65.02 meters. For our super cap setting, we got time as 6.34 seconds. Then what we kept, it was easy. Same position, velocity, acceleration graphs, same thing. Just different times and different initial velocity. So our change in velocity was just negative 10 meters per second squared times our time, which was 6.34 seconds. We got negative 63.4 meters squared. Our V naught is, again, our acceleration times our time for this, half our time to find it. And we got negative 31.7 meters per second. We took the absolute value, getting us our V naught of 31.7 meters per second. Our max height again was finding the area of this triangle, which came out to be 50.24 meters, and our total distance is just multiplied by 2 of our max height because it's a parabola, getting us 148 meters. I think that's it. Yeah, alright. And that was that. Thank you for your time.